In this video, we're going to look at solving equations using the roots of alpha, beta, and gamma. So just to start with, it's important that you write a cubic in the form ax cubed plus bx squared plus cx plus d, where a is the coefficient of x cubed, so in this case it's equal to a, just 1. B is the coefficient of x squared, so here it's just equal to minus 8. C is going to be equal to 28, and d is going to be that final constant value at the end. In this case, that's minus 32. If the roots are given by alpha, beta, and gamma, what we start by doing is by equating the b component, or not even equating actually, writing out that alpha plus beta plus gamma is going to be equal to minus b over a. There's two more equations that I'm sure you guys have seen before. So alpha times beta plus alpha times gamma plus beta times gamma is all equal to c over a, as well as the expression that alpha times beta times gamma are all equal to minus d over a. Equating that to using these values of a, b, c, and d, we get that minus b over a is just minus 8 here. C over a is 28 divided by 1, which is 28. Minus d over a is just minus 32, so just positive 32. This is going to be very useful for the rest of our question. And let's move on to that rest of the question. So for part I of the question, what we want to do is form a common denominator by multiplying all these three denominators together. In this case, it will multiply to alpha, beta, gamma. To go from the first fraction to the final answer, we multiplied beta gamma to the denominator, so we also do that to the numerator. Moving on to the second term, what we multiply to beta to get to this expression here is alpha gamma. So we're also going to multiply the numerator by alpha gamma. So it's again all over that same common denominator. In fact, let's put it all over one big common denominator just to ease things up. In a similar way, with that third fraction, you have to multiply to the top and bottom alpha beta, so I'm just going to very quickly do that. And now that we've got these expressions that are formed beforehand, we can just substitute the numbers that we got for them. So beta gamma plus alpha beta, that all adds up to 28. And you're dividing that by alpha beta gamma, which is all 32. And then 28 divided by 32 is 7 over 8. And that's everything for part I. For part 2 of the question, it's a little bit longer to do because you have to expand everything out, but let's do that. Alpha times beta is just alpha beta. Alpha times 2 is 2 alpha. That's a positive 2 alpha. 2 times beta is plus 2 beta. And then 2 times 2 is 4. You're multiplying onto all of that, gamma plus 2. So let's do that now. Alpha beta times gamma is just the multiplication of all three. Alpha beta times 2 is 2 alpha beta. 2 alpha times gamma is 2 alpha gamma. 2 beta times, oh sorry, I forgot this times this. So 2 alpha times 2 is plus 4 alpha. 2 beta times gamma, so it is a bit long, but it's just the same process, you're just repeating it yourself again. 4 times gamma is 4 gamma. And lastly, 4 times 2 is equal to 8. Once it's in this format, what you can do is spot relationships between the expression that you formed and these three expressions that I formed beforehand. So let's do that right now. Alpha, beta, gamma, that can directly be replaced with 32. Let's look at if we can spot this at any point. So we have 2 alpha beta. Do we have 2 alpha gamma? Yes, we do. And do we also have 2 beta gamma? Yes, we do. So that means that these three components combine to give you 2 lots of whatever this one component gives you, which is 28. So 2 lots of 28. Can we spot that first equation? Alpha plus beta plus gamma? Well, we can spot 4 alpha plus 4 beta plus 4 gamma, can't we? So that's 4 lots of the expression that I formed beforehand, which is minus 8. Sorry, I just realized this should be a positive. I don't know why I wrote minus 8. Sorry about that. Positive 8, and then we have that plus 8 at the end as well. Adding all of these numbers together would equal 128. And that's the answer to part 2 of this question. Moving on to part 3 now. For this part, we're going to use a common expression, which is that, well, a squared plus b squared plus c squared is the same as a plus b plus c, all squared, take away. Actually, I might as well write it out fully. So we use the fact that this is equal to alpha plus beta plus gamma all squared. But then you do also have to take away from it 2 lots of alpha beta plus alpha gamma plus beta gamma. I'm sure this looks familiar to you by now, but this first bracket just has everything that the first equation has, which is 8 all squared. So we can write this out as 8 all squared minus 2 lots of everything that this second bracket all has, 28. That's 64 take away 56, which is just equal to 8. And that's the final answer to this whole question. Hopefully everything made sense. Be sure to leave a like if the video helped and subscribe. I'd appreciate it a lot. Thanks for watching. Thanks for watching your video. I hope it helped. If you have any tutoring inquiries for A-Level Further Maths, be sure to hit my website up at www.excelineducation.co.uk.